What if the Big Bang was not the beginning of everything? Not as a theory, not as philosophy, but as a physical mistake? What if something real, something cold, ordinary, and measurable, entered our solar system carrying information from a time before our universe existed? In 2019, something did, and at first, nobody noticed. Modern cosmology rests on a powerful assumption. That time itself began 13.8 billion years ago. That before the Big Bang, there was no before, no space, no cause, no history. It is a clean story, elegant, and deeply comforting. But science progresses not by comfort, progresses by anomalies, by small cracks in ideas we thought were solid. And one of those cracks may have quietly drifted through our solar system, unnoticed, made of ice and dust. In August 2019, astronomers detected something unusual. A comet, but not our comet. This object, named 2I/Borisov, was moving too fast on the wrong trajectory. It was not bound to our sun, came from interstellar space, only the second such object ever observed. At first, this was almost disappointing. Unlike the mysterious cigar-shaped Oumuamua, Borisov looked normal, a classic comet, the same ingredients found throughout our solar system. Scientists analyzed its light, water vapor, carbon monoxide, cyanide. The verdict was reassuring.
An ordinary comet from another star system.
Case closed, or so it seemed. Years later, a group of researchers decided to reopen the data, not looking for something new, but for something wrong. A spectrum is not just color. It is a chemical fingerprint, passport burned into light. And hidden deep inside Borisov's spectrum, they found it. A signal that should not be there. An extreme abundance of nitric oxide, NO. In our solar system, this compound is almost non-existent in comets. Its formation requires violent, high-energy conditions. Conditions not expected in a calm protoplanetary disk. One scientist compared it to
finding modern industrial steel inside an ancient Roman structure.
Right material, wrong era, wrong universe. To understand why this matters, we need to meet a physicist who thinks about time very differently. Sir Roger Penrose, Nobel Prize winner, one of the architects of black hole theory. Penrose proposes something radical: conformal cyclic cosmology. According to this idea, the universe does not begin once. It repeats. Each universe, called an aeon, expands, cools, and dies. Stars burn out. Black holes evaporate, until nothing remains but radiation. And here is the twist. At that point, the universe becomes scale-free. Large and small lose meaning. Mathematically, the infinitely cold end of one universe is indistinguishable from the infinitely hot beginning of the next. The end becomes the next Big Bang. Penrose made a bold prediction. If a previous universe existed, its final black holes would leave imprints. As they evaporated, they would release enormous bursts of energy. He called the remnants Hawking points, scars carried across cosmic death into cosmic rebirth. Now imagine matter forming near one of these scars. It would not be normal matter. It would carry strange chemistry, unusual energy histories, anomalies, like excessive nitric oxide, like Borisov. The comet may not be special because it is alien, but because it formed from material touched by a previous universe. A fossil, not of life, but of time itself. Most scientists remain skeptical. They argue this is statistics, noise, pattern seeking in randomness. If you study enough objects, something weird will eventually appear, and they may be right. But science does not advance by ignoring anomalies. It advances by testing them. Soon, observatories like the Vera C. Rubin telescope will detect dozens of interstellar objects. Not one data point, but many. And then we will know. Maybe Borisov is nothing. Or maybe it is the first physical hint that our universe has ancestors. That the Big Bang was not a beginning, but a continuation. The question is no longer just, are we alone? It may be something far stranger. Have we ever been the first?